We'll start with a new example now of graphing functions again. So these are all graphing questions in paper 1, which means comes without the calculator. So the question is this. There's a graph given to you. The dotted line always means that it cannot take that value. So usually for vertical asymptote, you represent it that way. X equal to -2, and there is a function, it's -2, this is +2, and this is the horizontal asymptote whose equation is y equal to 2, and there is a, so as soon as you see this shape, this kind of shape, you know it's a rational function or a reciprocal function. The reason I know it's rational because in reciprocal functions we will usually have y equal to 0 as the asymptote. If it is having any other asymptote other than y equal to 0, that means there is a numerator and a denominator, which is why we are having a number. So that tells us that this is a rational function and not a reciprocal function. And the question also gave us that. The question said the function is of the kind a plus x upon b plus cx. And they are saying that the graph of this is represented in this way. Look at the graph and find out the values of a, b and c. That's the first part of it. So let's understand. The function is y is equal to a plus x upon b plus cx. The vertical asymptote. Where will the vertical asymptote be? The vertical asymptote will be where the denominator becomes 0. When does the denominator become 0? When x is minus b by c. Correct? So do I know the vertical asymptote from the graph? Yes, I know that it is equal to -2. So b by c is equal to 2 is my first equation that I come to know from that graph. Next, what else do I know? I know the intercepts. I know the x-intercept and the y-intercept. How do I find intercepts? X-intercept is when y equal to 0. When will y be equal to 0? When a plus x is 0 or x is equal to minus a. What is the x-intercept there? It is 2. So 2 is equal to minus a. So a is -2. So I got the value of a. I also have the y-intercept in that. How do I find y-intercept? Y-intercept means put x equal to 0. So a by b is the y-intercept and a by b is -2. A by b is -2, and a is -2, so b is 1. If b by c is 2 and b is 1, then c is half. So I got the values for all of them, a, b and c. So let me rewrite the equation. One more information is there in the graph actually, horizontal asymptote. You know how to find horizontal asymptote. So let's substitute the values and see now. A plus x, so x minus 2 upon b plus cx, b plus cx. So I can rewrite this as 2x minus 4 upon 2 plus x. This is my function. How do I find the horizontal asymptote? Well, horizontal asymptote means where does the function go when x becomes very large? So I will rewrite this as 2 minus 4 by x upon 1 plus 2 by x. When x becomes very large, this 4 by x and this 2 by x will become negligibly small. And therefore, what will be left is y equal to 2 upon 1, which is 2. That's your horizontal asymptote. Is that what the horizontal asymptote is in the figure? Yes. So what answer we got for ABC is matching with what we have already seen in the graph. So let me rewrite the equation. It's 2x minus 4 upon x plus 2. This was the first part of the question, that find the values of ABC. The next part says graph. Graph means basically sketch. Sketch the graph of b plus cx upon a plus x modulus. So it is the modulus of the reciprocal. So that means they are asking us to graph modulus of the reciprocal of the function x plus 2 upon 2x minus 4. So let me first graph this x plus 2 and 2x minus 4 and then tell you how the modulus looks like. So x plus 2 upon 2x minus 4, the vertical asymptote will be at wherever the denominator is 0, x equal to 2. The horizontal asymptote will be 1 plus 2 by x upon 2 minus 4 by x. What is the horizontal asymptote? When x is very, very large, I will reach to half. So y equal to half is the horizontal asymptote. What are the intercepts? When x is 0, y is minus half. And when y is 0, x is minus 2. So my graph looks something like this. Apologize about the not being very good with the thing, but this is the shape and these are my intercepts, minus half and minus 2. I want a reciprocal. Reciprocal I've already done. I want the modulus. What does modulus function do? Well, modulus function will take all the negative values and put it positive. Where is the negative value? After minus 2, this part is negative. So this is where it will become positive. So this blue portion, which was negative, will now be flipped and will look in the positive region because it is the modulus. If you want, I will just graph it on Desmos and show it to you. It's absolute value of x plus 2 we will put one more bracket so that we can divide this, divide by 2x minus 4. Do you see there is a half here, there is a minus 2 here, and if I draw y equal to 0.5, you will see the horizontal asymptote. Do you see? This is what we had graphed here. So it is important to understand step by step how to go about this graphing. It's not difficult, provided you know what is the question asking you to. Okay, let's look at a new question. Again, a graph is given. See, you cannot use calculator in these questions because the equations are not given, only the graphs are given. So you have to look at the graphs and understand this. So this is the graph of y is equal to fx, and the question says sketch f of minus x and then modulus of it. Okay, so let's do it step by step. What does f of minus x do? It reflects on the y-axis. So the right comes to left and the left comes to right. So your reflection will look something like minus, not to scale, but no, if this was minus a, then this will be a. If this was minus b, then this will be b. If this was c, then this will be minus c. So that's the kind of symmetry I'm showing. This is f of minus x. It flips. The right goes to left and left goes to right. What about modulus? Well, modulus will take the negative portion of the graph and flip it to the positive part. Nothing else. So it doesn't change anything else there. Let me show you an example graph here, then you may understand. So if I draw, let me remove these two. If I draw x cube plus 2x square, okay, this is my graph, say for example. I want to first do negative of it, right? So wherever there is x, I'm going to replace it by minus x. So it flipped. Even if I put here minus x, it doesn't matter because it's a square operation. But let me show you. Right, so first thing happened was it flipped. The next thing is I'm taking absolute value of it. So absolute value of it. Do you see what happened? Whatever was the negative portion, that became, let me graph this separately and show you. Whatever was the negative portion, that became positive. The positive remained as it is. That's what I'm doing here. It flipped, then whatever remained in positive will stay as it is. That negative portion will be flipped up. That is what the modulus function does. Okay. Next example is sketch x minus 12 upon square root of x square minus 4. So what are important points here? First of all, I have to understand that in the denominator there is x square minus 4 and it cannot become negative, right? Because there is a square root sign and square root cannot have negative. When will it become negative? When either x is less than minus 2, the left, or rather whenever x is between minus 2 and plus 2, right? Then it will be less than 4. Beyond that it will be greater than 4 x square, so it's fine. So the function will not exist between minus 2 and plus 2. At minus 2 and plus 2 there will be a vertical asymptote. What happens on the right of 2 plus 2? So there will be, the denominator will go on increasing and the numerator will be more and more negative. So the denominator will start bringing it to lesser and less negative value. But it will remain negative till 12. Till x equal to 12 it will remain negative. After x equal to 12 it will start becoming positive. At 12 it will be 0 and then after 12 it will become more and more positive. What about the negative side? Negative side, as x becomes more and more negative, the denominator is symmetric but it will continue staying negative. Let's look at this graph. So here the question was not actually to sketch the whole thing without the calculator. It was more to write down the intercepts and the asymptotes. So like we identified, the intercepts are at x equal to 12, y will be 0. The vertical asymptotes are at +2 and -2. The horizontal asymptote, when x becomes very, very large, the y value is close to 1, because I'm dividing numerator and denominator by x. X when goes into the square root becomes x square, so that's the reason it is. And when x becomes very, very large, this 12 by x and 4 by x square will become negligible, and I'll be left with y equal to 1. So the horizontal asymptote is y equal to 1. So this is where the graph will go. And on the negative side, the denominator is positive. When x is equal to, when the denominator and the numerator will become equal, that's when it is equal to 1. Otherwise, it always stays in the negative region. So let's graph this and check. X minus 12 divided by square root of x square minus 4. So look at the graph. I'll draw the y equal to 1 line, so you know that it is the horizontal asymptote. This left side remains only in the negative region. Do you see? And the right side goes at x equal to 12, it becomes 0. It starts negative, and after that it starts becoming positive and goes towards 1. Negative side always remains negative. If you want to test, try a few values on the left of -2. And if you want to substitute x equal to 2 and x equal to -2, you will realize how they are the vertical asymptotes. So there is nothing in between x equal to 2 and x equal to -2. The graph does not exist there. It only exists on the right of 2 and on the left of -2. Okay. So that is the sketch. So what we mean to say is that the questions are to see how are you able to sketch something which is not familiar to you. We'll look at last question. The question is mod of x plus 1 minus mod of x minus 3. Let's graph them individually first. What is mod of x plus 1? First of all, this is the modulus function. This is y equal to mod of x. Correct? It's a straight line. Even on the right or the left, it behaves the same way. X plus 1 means horizontal translation by 1 unit. So it is at -1. And when x is 0, y is 1. So these are the intercepts, and this is how the function looks. What is x minus 3? It is shifting 3 units to the right. So here, and when x is 0, y is 3. That's the y-intercept. The question says x plus 1. So there is a red graph minus this blue one, minus the blue graph. So how do I subtract? So best thing first to look at is the intercepts. When x is 0, what happens? When x is 0, I get mod of 1 minus mod of -3. So 1 minus 3 is -2. So my y-intercept is -2. after 3. Let's look at these points because these are my main points in the individual graphs, right? Let's look at x equal to 3 and after that. At x equal to 3, what happens? At x equal to 3, the value becomes 4 minus 0. So it remains, it is 4. When x equal to 4, what happens? 4 plus 1, 5 minus 1, again 4. At x equal to 6, 7, 8, if you go on the right of 3, the function continuously stays at 4. Similarly, let's look at minus 1. What happens when x is minus 1? When x is minus 1, y is 3. Minus 3, sorry. Take any other value on the left of minus 1, you will see that the value continues to be minus 3. So it is 4 on the right of 3 and it is minus 3 on the left of, and it passes through 2, so that's my graph. Like a Z, like the letter Z. It's 4 afterwards, it is minus 3 later, and it passes through minus 2. Let me graph it on Desmos to show you. All the 3 I'm going to graph so that you can see what is happening. So I will graph absolute value of x plus 1. Do you see it is shifted left? Sorry, x plus 1. And then absolute value of x minus 3. So it's shifted to the right. And now I'm subtracting. I'm saying this minus the other function. Do you see? So I'm going to remove this now and see. There is an x-intercept of 1. There is a y-intercept of minus 2. And then all these values, it stays at minus 4 and it stays as plus 4. Sorry, I think I made a mistake. I wrote minus 3. It's minus 4 actually. Sorry. It is minus 4. Correct. When x is minus 1, this will become minus 4, right? I made that mistake. So minus 4. So the function is like a z from plus 4 till minus 4. Any value of x on the left of minus 1 is minus 4 and on the right of plus 3 is 4. So that's how we think about functions and their graphs without the calculator.